This video is going to be explaining exponent rules. There are multiple different rules. We have the product rule, the quotient rule, the zero exponent rule, the power rule, and inside we have the expanded power rule, and then the negative exponents. First one we're going to talk about is the product rule. The product rule is when you want to multiply when two bases are the same. When the two bases are the same, we're going to write the base and then we're going to add the exponents. As an example, we have x to the m times x to the n. So the bases are the same. So we add the two exponents. It becomes x, the same base of x, raised to the m plus n. So do a couple of examples. The first one is x to the third times x to the eighth. Now because we are doing the product rule, because we are multiplying the two bases, the bases are the same. We have the same base of x on both of them. That means that we can do the product rule. We're going to write that same base so that x is the base. And then we're going to add the two exponents. So we have a 3 plus 8. So what happens is the base stays the same. So we have x raised to the 3 plus 8 is 11. So x to the third times x to the eighth is equal to x to the 11th. And that's as simplified as it can go. If the base was a number and you could simplify it further, then you should do that. But since the base is a letter, it's a variable, that means that it cannot simplify further. And there's only one letter x in the problem. So that means that we're done. On part B, we have 2 to the fourth times 2 to the second. Now because again we have the same base, we can do the product rule. So again, we write that base, that 2, and then we add the exponents. So it's 4 plus 2. This is equal to 2 to the 6th. Equals to 2 to the 6th power. Now, because this has a number for the base, 2 to the 6th, can be simplified further. 2 to the 6th power, if you plug in your calculator, is 64 because it's 2 times 2 times 2 times 2 times 2 times 2 again. There's 6 times in total. That's equal to 64. So 2 to the 6th is actually 64. You only do that if you have a base of a number and an exponent of a number. That means you can simplify it further because it's just numbers. Part C, or example C, has multiple letters in it. So we're going to follow the same pattern. We're going to follow the same instructions. This is a multiplication. This is x squared y times x cubed y to the fourth. So because we have an x squared in the first set and then we have an x cubed in the second set, those two will actually go together. We have a y and a y to the fourth, so those two will need to go together. We combine our like bases. So when we combine our like bases, our x and x will go together. We keep it x. And then we add our exponents. 2 plus 3 is 5. So we have x to the fifth, but then we also have our y's. Since they have the same base, we write that same base, and we add our exponents. Now this y is actually raised to the first power, because there is one y here. That means it's going to be a 1 plus 4, which is a 5. So our answer for this problem is x to the fifth, y to the fifth. That is the product rule. When you have the same bases being multiplied, you add the exponents, and that's for any type of base, letters or numbers. The second rule is the quotient rule. This is when we're dividing. So when two bases are the same, again, they have to be the same bases. Two bases are the same. We're going to keep the base, we're going to write the base, but we're going to subtract the exponents instead of adding them. Now, you can subtract from top to bottom or bottom to top. You can subtract, most people will subtract, it's going to be like 5 minus 2 or 5 minus 8. But what I like to do is I like to keep the variable where the bigger exponent is. I'm going to make a little note right here. because sometimes when you subtract, you end up with a negative value. So on the example here, we have x over x, so we can keep our base, m over n, so we would subtract our two exponents. But the problem being is if we subtract 5 minus 8 would give us a negative value. And we haven't gotten to the negative exponents yet. So what I like to do is just keep the variable where the bigger exponent is. That will eliminate having the negative exponents, and that will actually make it less work for us. So if we look at our examples, we have x to the fifth divided by x squared. Now, because we have the same base of x and x, that means that we can do something with the exponents. Since we're dividing, we do want to subtract our exponents. Now, do you notice that the 5 is bigger than the 2? That means that our variable should actually stay on the top of our answer. So when we write this, it'll be x raised to the, because x will be on top, it will not be on the bottom of the division. We're going to subtract 5 minus 2. 5 minus 2 is 3, so it's x to the third. So x to the fifth divided by x squared is x to the third. And the reason this happens is because you have 5 x's on top, 2 x's on the bottom, and whenever you have multiple x's, they can cross each other up because they equal to 1, but we're still left with 3 x's on the top. On this second example, we have 3 to the fifth divided by 3 cubed. Again, you have the bases are the same, it's 3 and 3. So that means that we can keep our base, so it becomes 3 raised to something. Now, again, your 3 to the fifth, the 5 is actually the bigger exponent, so that means our answer is actually going to be on the top of a fraction. So it's going to be 3 raised to the power of, and it's going to be 5 minus 3. 5 minus 3 is going to be 2, so it's 3 raised to the second power. Now again, because this is a number and the exponent is a number, that means you can simplify that. That's just 3 squared. 3 squared is equal to 9. That is how you would simplify that value. On part C, we're going to do the same thing, but this time we have different multiple letters. We still focus on the ones that go together. So our x squared and x, since we have 2 letter x's in here, we want to simplify it down to just 1. So let's focus on our x's first. The x squared is bigger than the x, so that means our x's will stay on the top of our fraction bar. So I don't have anything on the bottom yet, so I'm just going to go ahead and go with the x. It's going to be 2 minus 1. Again, that exponent of this x is a 1, so 2 minus 1 is 1. Then we're going to go to the y's. Again, the y's, since they have the same base, that means we can do something with their exponents. Since we're dividing, we're going to subtract. Now, the y to the fifth is bigger, so that means that the letter y, our base of y, will stay on the top of the fraction. So we're going to have y raised to the, and we're going to do the 5 minus the 3. 5 minus 3 is 2, so it's going to be y to the second. Now, if these were reversed, we would have had the y on the bottom and still subtracted the 5 minus 3. But because the y to the fifth was on top, it stays on top. And there's no more letters, and nothing went to the bottom of the fraction to the denominator, so then this is our answer. Now, another thing you can do is you can just have x, y squared, because x is x to the first as well. You do not have to put that 1 there, but it is always good to know that that is there, so it's sometimes better to write it. The next rule is the zero exponent rule. The zero exponent rule states that any base except 0 raised to the 0 power is equal to 1. So what you got to be careful about is what is raised to the 0 power. Okay, you have to actually check to see what that exponent is connected to. So if we look at this first example, actually up here it says x to the 0 equals 1. That 0 is attached to the x and nothing else, so this concept right here is equal to 1. This example A, our exponent of 0 is connected to the y, and there's nothing else in the problem. Therefore, this entire problem is equal to 1. On example B, we have 6 raised to the 0 power. It is any base, 6 is a base because it's holding up that exponent. That 0 is attached to that 6 and only the 6, and there's nothing else in the problem. So this entire problem is equal to just 1. On example C, again we have an exponent of 0, but do you notice that the 0 is attached to the parentheses? So because it's attached to the parentheses, everything inside of the parentheses is actually raised to the 0 power as well. That means that everything inside of the parentheses is actually just equal to 1. So if there was anything outside of it, that would be different. But because the 0 is attached to the parentheses and not just one specific base, it's attached to the entire set of parentheses, that means that this entire set of parentheses is 1. And we'll look at some other examples of when there's a difference between that. So just be very careful about what your exponent is attached to, because it's attached to what it's directly attached to, like the 6, it was directly attached to the 6. This one was directly attached to the parentheses, and the parentheses includes all of that. The next rule we're going to talk about is the power rule. This is when to raise a power to another power. So when you basically have two exponents attached to each other. We're going to write the base, but then multiply. We're going to multiply the exponents. The exponents. Not multiply the numbers, we're going to multiply the exponents. So what that means, if we look here, we have one base, but then we have parentheses and two exponents. We have the m attached to the x, but we have the n attached to the parentheses. So what we do is we multiply the n times the m, but we keep whatever that base is. So it's going to be x raised to the m times n. So as an example, we have x raised to the 3, then raised to the second. We have a power and then another power directly attached to it. So what that means is we're going to keep that base. We're going to keep that base of x. And then we're going to multiply the two exponents. That's a 3 times a 2. So what this becomes is we keep the base. X raised to the power of 3 times 2 is 6. The next example, we have the base of 3 raised to the second power, and then that's raised to the fourth power because that 4 is attached to that parentheses. So it's attached to that 2. It's going to multiply to that 2. So we're going to keep our base of 3. Then we're going to multiply our two exponents because it's an exponent raised to an exponent or a power to a power. So we have a 2 times a 4. That becomes a 3 raised to the 2 times 4 is 8. But again, as earlier, we have a base that's a number and an exponent that's a number. That means that we can actually simplify it to just a number. Numbers and numbers will simplify to numbers. So 3 to the 8th, if you put in your calculator, would be 6,561. That's actually what that simplifies to. On example C, we have z to the 5th raised to the second power. So again, we have a power and another power directly attached to each other. So we keep the base of z, and then we multiply our two exponents. 5 times 2 is 10. The difference between this rule and the product rule is that we're not multiplying bases. We only have one base, we only have one letter z, and then we multiply the exponents instead of adding them. So that's the power rule. Now on the next rule, it's just the expanded power rule. That's when we have multiple bases. But again, we only have one specific letter of the base. So like here we have x and y. We still only have x raised one time. We only have y one time. But we also have it for the division as well when we are dividing. We have it when x and y are multiplied together and x and y are divided to each other. So what we have to do is make sure all of the exponents. So we're going to multiply all exponents. What that means is, just like before, when we take that m, the outside m, we have to multiply to each individual exponent. So the x has an exponent and the y has an exponent. That's why it becomes x to the m, because technically this x is raised to the first power and this y is raised to the first power. So we have to multiply the m times the 1 and the m times the 1. The same thing will happen over here when we're dividing. Because x and y are different bases, these cannot subtract each other. The exponents can't subtract. But the x is raised to the first power and the y is raised to the first power. Even though it's division, we still have to make sure we multiply the outside exponent to each exponent in the problem. So it becomes x to the m divided by y to the m. This cannot simplify further, again, because x and y, the bases, are not the same. Now, when it says to all exponents, that includes every single exponent. So if we look at example A, we have 2a in parentheses, all of that raised to the third. Because all of it's raised to the third, that means that we have to multiply the 3 to every exponent. Everything has an exponent, including the 2. Now, we do not do 3 times 2. We multiply the exponents. Again, multiply all exponents. The exponent on the 2 is actually a 1, and the exponent on the a is a 1. So what this becomes is it's 3 times 1. So it becomes, we keep the base of 2, then we do 3 times 1, 2 to the third. Then we have the base of a, and again we multiply 1 times 3, so that's 3. Now, this 2 to the third and a to the third are separate parts to it, but they are still together because this is still a multiplication of the 2 bases. But because the bases are not the same, we can't do anything with the exponents. However, we do have a base of 2 and an exponent of 3. These are numbers. That means that we can simplify this one to an actual value, but we cannot simplify a to the third any further. So 2 to the third is actually equal to 8. So we have 8. This 2 to the third becomes 8. A to the third stays as a to the third. And that's our simplified answer. We cannot go any further from there. On example B, we're going to do something very similar. Okay? We have 2 bases. We have an x and a y. That's important to know. What bases do you have? How many bases do you have? We have 2 letters, but again, a base can also be a number. So that means that we have to multiply the exponents because everything is raised to the 4th power. So everything has an exponent. X squared already has the exponent of 2, and y has an exponent of 1. So when we rewrite this, we take this 4 and multiply it to the 2 and to that 1. Because we don't have any of the same bases, what our answer is going to be our answer. So we have x raised to the 2 times 4 is 8. And then on the bottom, because the denominator, y is in the denominator, we have a 1 times a 4. So it's y to the 4th. And again, these bases are not the same. Therefore, we can't subtract our exponents. On example C, again, we have to figure out how many bases we actually have. We have a letter of x, but we also have a number of 6. These are both bases. All of this inside the parentheses is raised to the 2nd power. So again, 6 has an exponent of 1. So we have to be very careful about that. So what we do is we multiply this exponent of 2 on the outside to the exponent of 1 and the exponent of 3. We are not multiplying 2 times 6. Be very careful about that. We keep the base of 6 raised to it becomes a 1 times a 2, which is 2. Then we have the base of x. We multiply the 3 times a 2, which is a 6. Now, because we have a base of a number and an exponent of a number, this can simplify to something new. So 6 squared is 36. And then x to the 6, because it's not a base of a number, and there's only one letter x in here, so that's good. That means that it's going to be 36x to the 6th. Okay, so again, you multiply the exponents. On example D, we have multiple bases. So again, we got to figure out how many bases we have. On the numerator, we have a 2 and an x. Those are both bases. So 2 is raised to the 1st power, and x is raised to the first power. In the denominator, we have a 3 and a y, so those are both bases. The 3 is raised to the first power, but y is already raised to the second power, so that actually helps us. So now we have to multiply this 3 to every single exponent in the problem. So we're going to keep our bases. Becomes 2 raised to the 3 times 1 is 3. Base of x. 1 times 3 is 3. Divided by, now again our base is 3, we still have to multiply our exponents together, so it would be 3 raised to the 3 times 1 is 3. The next base is the y, multiply the exponents is 3 times 2, which is 6. Now the only thing left to do is to simplify. If you notice on the numerator we have a base of a number and an exponent, that means we can simplify this value. In our denominator we have something similar. We have a base of a number and an exponent. We can simplify that. So when we simplify that, we will have 2 to the third is 8 on our numerator. We'll keep our x cubed. Divided by 3 to the third power is 27. And then we keep our y to the 6 because that can't change. Now, we're not completely finished yet because we always have to check because we have numbers. Now, our x and y can't simplify further because they're not the same bases, but 8 and 27 are numbers, just actual numbers, so we can see if that will simplify further. We would plug that into our calculator, and we would see if it will simplify further. So if I plug 8 over 27, so 8 divided by 27, I get a decimal value, but remember, we don't want decimals. We want to hit math, the math button, and we want to hit enter. It gives us back to 8 over 27, so that means that this is as simplified as it can get. So when you write our answer, we write it out as 8x cubed divided by 27y to the 6. Because our variables will end up staying the same, the bases of x and y will stay the same. So this is our final answer because 8 and 27 cannot simplify further, and that's okay. Rule 6 is the negative exponents. I was talking about this earlier when we were dealing with subtraction. Whenever you have, if a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. So I'm going to highlight that. The sign of the exponent is changed. And again, it's very important to understand that we're dealing with the exponent. The sign of the exponent is changed. We don't want to have negative exponents, so that's why we would want to move it. A number that's negative is perfectly fine. A number that is negative is fine. The exponent that is negative is not fine. So if you have a problem that has x raised to the negative m, this is really a 1x raised to the negative m. You always have a number in front, even if you don't see it, it's a 1. So we look again to see what is the exponent attached to. This negative m is only attached to that x. So that x would need to move across the fraction bar. So right now it's above the division. So that x to the negative m would move to the bottom. But the exponent then changes. Nothing else changes. So what didn't move was the 1. So that 1 stays in the numerator. If you have 1 over x to the negative m, again, that negative m is attached to that x, and it's in the denominator of the problem. So what happens is this moves to the top, and it becomes 1x to the positive m. Again, that 1 didn't move, so it stays up top. It's 1x to the positive m. Another thing that you can do, you don't have to do this method. You can, but if it's easier for you to do them individually, you're more than welcome to. If you have parentheses, and you have the entire parentheses raised to the negative exponent, what you can do is actually just flip the entire fraction. So the numerator becomes the denominator becomes the numerator, and then it's raised to the positive power. And what that is again, just doing an expanded power rule and then flipping the numerator and denominator from there. But you can do that as at the beginning, or you can do them individually. So let's look at our first example, x to the negative 3. So again, we do have a number in front. This is a 1 in front. We have to figure out what is attached to that negative exponent. We have a negative 3. This negative 3 is attached to just that x. So that x is what has to move. So on the top, the 1 did not move, so we put the 1 on the top because we keep it. We need to move the x to the denominator because on the top it's negative. We don't want that. The base stays the same, so we have an x, but then the exponent changes to the positive value, so it becomes x to the third in the denominator. 1 divided by x cubed. On example B, again, we're going to look to see what is attached to this. Negative 2 is attached to the 4. And right now, it's in the numerator of the problem, so it does have to go to the denominator of the problem. So the base is a 4, and then it becomes to the power of a positive 2. Now the question is, what is in the numerator? Well, we can think about this as, earlier we had 1 times x. Well, this can also be a 1 times 4. 1 times 4, so that really means we have a 1 in their numerator. If everything is moved to the denominator, every single thing in the problem is moved to the denominator, a 1 is in the numerator because everything is multiplied by 1. Now again, we have 4 squared, so that means we can simplify that. 4 squared is 16, so this is really equal to 1 over 16. And that's as simplified as that can go. On example C, we have a negative 4 and then a y to the negative 2. Now the question is, which part needs to change? The only part that changes is the negative in the exponent. So this negative on the 4 does not need to change. Only the y to the negative 2. This negative 2 is attached only to the y. Only to that y. So only that y will move to the bottom. So that negative 4x to the 5th will not change. That actually stays in the numerator, negative 4x to the 5th. But then the denominator becomes, we keep the base of y, then the exponent turns to a positive 2. And we can't simplify that further, so that's our answer. This is what I was talking about earlier with making sure that you know what is attached to. Because if it's attached to parentheses, then that becomes different. Moving to example D, we have x squared over y, all of that raised to the negative third. This is that example I was talking about up here, that you can do it separately. You can actually multiply your exponents to each other, so 2 times negative 3 and then 1 times negative 3, and then flip them accordingly. However, because this is all in one thing, I can actually go ahead and flip them because everything's going to be having to move anyway. So because everything's attached to a negative 3, I can put my denominator in my numerator and my numerator in my denominator. So I put y over x squared. And now that's all raised to the positive 3. And then now I have no negative exponents. Now I can actually multiply my exponents because this is the expanded power rule. And I can get y to the third power over x to the 2 times 3 is 6. It's a little bit easier to do that than having, you could have had x to the negative 6 over y to the negative 3, and then you would have had to have flipped those as well. Okay? So this can be beneficial if you have something, all of its raised to a negative, you can just flip the numerator and denominators to each other. All right, example E is kind of putting it all together. So we're going to have a multiplication. We have 2 parentheses, so we have multiplication. We have negative exponents. We do not have a power raised to a power. There's no exponents on the outside, which is nice. So we just have to be careful about our numbers. Okay. So first, you can try and get rid of your negative exponents, but I would rather go ahead and get everything together first and then worry about my exponents. So first, I'm going to look at my numbers. Is a 3 times a negative 2. So I'm going to have 3 times a negative 2. And I'll simplify that in a second. Then my x's is going to be, so since I multiply my x's, I can keep my base, and then I can add my exponent. So I have a negative 2 plus a 1. And then the y's, again, since I have the same base, I can add the exponent. So that's a y to the first plus a negative 3. Now, all three of these are technically multiplied together. So when I simplify it, it'll make things a little bit easier. So I have 3 times negative 2 is negative 6. X raised to the negative 2 plus 1. Negative 2 plus 1 is negative 1. So I have x raised to the negative 1. Then I have y raised to the 1 plus negative 3, which is really 1 minus 3. So that's y to the negative 2. Now we can actually worry about our negative exponents. Attached to the 6 is a negative, but that's not a negative exponent, so that is fine. There's no negative exponent here, so this will stay. The x is raised to the negative 1. That negative 1 is attached to that x, so that will have to move. On the y, we also have an exponent of negative, so that negative 2 is attached to that y, so that will also have to move. So what stays is that negative 6. So we're going to have negative 6 in our numerator, because it stays on top, divided by the x goes to the bottom, it becomes x to the positive 1, and the y will go to the bottom as well, it will become y to the positive 2. That's how you would do multiple different rules together. We didn't have any division. We didn't have a power raised to a power, but you would use that same concept. You would actually do individual parts and then break it down to get your answer. The last thing I want to do is caution you about that negative x. Again, we've already talked about this a little bit with that negative 6 right here. Did not have to move. The negative in front does not mean you have to move the base to the bottom or to the top. The negative stays as it is. Negative 3 is equal to a negative 3, not to a 1/3. You don't move it. So please remember that an exponent applies to only the factor it is directly next to, unless parentheses enclose other factors. So for example, this is what I was talking about earlier with the parentheses. This 2 is attached to, the square is attached to the parentheses. So the entire set of parentheses is squared. That means that entire set of parentheses is multiplied to each other. So squared means you write it twice. So it's that negative 3 times a negative 3. Negative times a negative is a positive. That's equal to a positive 9. However, the same example, except with no parentheses. So on example B, that squared is technically only attached to that 3. So only the 3 is being squared. So we really have a negative on the outside times 3 squared means you write 3 twice. 3 times 3. So a negative times 3 is a negative 3. Times 3 is a negative 9. So they look the same. The problems look the same, but they aren't the same because of those parentheses. That's why I've always said be very careful about knowing your parentheses. These are exponent rules. These have all the exponent rules on there with examples. So just make sure you're very careful about what your exponent is attached to.